We're going to go through the exercises 4.3, and this is number 1. And it says we have this graph here, and this section down here, they say the vertical shading of the red, and this is red in the book or in the online, is 18. So this area is 18, and the oblique black shading is 6. Okay, so it says, what's the integral from A is here, B is here, C here, from A to B of f of x dx? Well, it would be, since it's below the x-axis, it would be negative 18. And from B to C, it would be a positive 6. And from C to A, from A to C, A to C would be A to C would be negative 18 plus 6, which is negative 12. And if we do the absolute value of this negative values would be up here. So we'd have the A to C of the absolute value, which actually gives us the distance, would be 18, positive 18 plus 6, which should be 24. Number 2. We have this picture. I've tried to put the dimensions on here. It's kind of small, so hopefully you can follow me here. It says from negative 4 to 0, from negative 4, which is here, to 0, the area under the curve is, well, this is 4 across. And down here it's at minus 1, so there's minus 1, minus 2, and these two will make another one, so it would be negative 3. Is it minus 1, and these are half and half, and 1 and 1. So negative 3. If the vertical shaded area in the graph is A, so if this is A, estimate from excuse me, from negative 4, from here to here. Well, this area is all negative, this area is all positive, and so those two cancel each other. And if this area is A, the estimate for this would be negative A. If the area is A and it's below the graph, it's negative A. Find the average value of this linear equation. Well, linear equation, it's over from 3 to 8. Well, if it's a linear, it's a positive slope, it'll be going up. And so the average value, if we were to level this off, would be just the average value of the height of here and the height here. So at 3, 7 times 3 is 21 plus 1, 22. So it's 22 high on this side. And 8 times 7 is 56, plus 1 is 57. And so the average value will be 22 plus 57, which is 79, divided by 2. Or, see, that would be 39.5. Okay, 4. Find the average value of these. So, from 0 to 2 of f, and this is f, and 2 is here. So, if we were to do the boxes, and just to figure out the area, this is a half, and this is 1. So that's 1 by a half, so or if you will, a quarter and a quarter and another quarter. So the area of all this is 3/4, and then there's no more area. So the total area under the curve from 0 to 2 is 3/4. So that would be the integral from 0 to 2 of this graph, the total area, 3/4. And to find the average height, you have to take this and divide it by the width. And the width goes from 0 to 2, so we divide by 2. So we get 3/8, which is about here. If all this area was leveled out between 0 and 2, the area would be about 3/8 high. And that's what's called the average value. What's the average value of G? Well, we have area here, and this would fill in that, and so it's 1 high and a half wide, so it's 1/2. So the total area under this graph, none here and a half here, is 1/2. And if it's spread out evenly over 2 units, we'd have to split this in half. So 1/2 divided by 2 is 1/4, which is about this high. If I took this area and shook it down, it would fill that. What is the average value of f of x times g of x? We're multiplying. So for this first interval, this function is not 0, but this function is 0. So something times 0 over that first 0 to 1 is 0 when we multiply those two. And then for the second part, this one's 0 and this one's not. So for that second part, from 1 to 2, the product is going to be 0. So the average value, since there's no area under the product, if you actually do the product of these, you get 0. So is the average value of f, which was 3/8, and the average value of g, 1/4, equal to the average value of f times g, which was 0? And the answer is no, they are not equal. Okay? 5. And this graph was kind of small, so I made a picture of number 5. Here's number 5. And it says, estimate the integral from -3 to 3. From -3 to 3. So I'm going to do that by counting squares. So this square is missing about that much, which might be about this area. So this plus this would be 1. This plus this might be 2. And this plus this might be 3, 4, 5, 6. And this is not quite a full square, so maybe 3/4. So I'm guessing -6 3/4. That's my rough estimate for this area. Over here I have I have 1 minus a little bit there, and I'm thinking that probably this and this will make 1, so that's 2 and a little bit more than 2. I'll call it 2 1/4, but I think that's a little bit too much. So the total area, what was the question here? Estimate the integral from -3 to 3 of f of x. Well, that would be, oops, did I do this? Let's see. Look here, I think I added that. I want to do, this would be 1, and this would be not quite another 1, so 1 3/4. I added that piece on there, and they said stop at 3. So I'm going to go 1 3/4 to here. And so if this is -6 3/4 and this is 1 3/4, I get a total of -5 approximately. Which of the following average values of f is larger? The average value from between -3 and 3, from here to here, or from 0 to 3. 0 to 3, this would be more positive, and so its average value would actually be probably something like this. If I take this negative away from this area and then level what's left, I get something like that. And if I do from -3, which you've got a lot of negative and some positive, the average value would probably be down here someplace. Taking this away from that and then smoothing it out. So it would be larger between 0 and 3. Okay, number 6. So we have between, so I'm going to draw kind of a rough graph here. Gotta be careful here because we're dealing with negative x values, all of these. So over here, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. There's -9, -7.5. And then we have -6 and -4.5. So we got these places. And the area between -9 and -4.5, all the area between here and here is 10. But between -9 and -7.5, it's 8. So I could go, this area is 8, and it's positive. The area between -6 and -4.5 is 10. So I'll just go like that and call it 10, a little bit more than that. And if the area from here clear to here is 10, that means the area in here has to cancel that 8, so it must be -8 to give 8 minus 8 plus 10, a total area of 10. So what's the area from -7.5 to -6? It's -8. Now, it says, what's the area from -6 to -7.5? Well, that's going backwards. So if I want to change these around, I would change this to -7.5 to -6, so it's going from left to right. I'd have to put a negative on it. Then I want to do 10 times the area of the curve between there. Well, that's -8 times 10 is -80. And then if I have a graph that's -8 the whole time, this is kind of a whole different thing. This is 10 times what's under this curve. Then it says a -8. Well, if I have a graph that between -7.5 and -6, it stays -8 down. Remember, this -8 was the area, but this stays down -8, so on the second part here, down -8 for 1.5. So that area, -8 times -1, or no, this is a positive 1.5 plus 1 1/2. So that would be -12. And then we have to take the, so let's see, make sure I get this right. So under -8 for 1.5 would be -12 area, and the area under F was -8 times 10, -80. So this is -92 And then we have the negative of that, which makes it plus 92. Hopefully I did that correctly. Okay. Number 7 says we have a velocity equation that looks like this. It's piecewise defined, moving along the x-axis, velocity, and assume it's moving right. So this, during this time, it's moving right. It's positive velocity, so it's moving right. And then it turns around, goes backwards, and speeds up, and then slows down until it stops, and then it goes forward for a little bit. Write an expression involving definite integrals whose value is the total change in position of the object from 0 to 4. Okay, so we would have the integral from 0 to 1.5 of this, which is, it has a -2 slope, and it has a y-intercept of +1. That would give the total change of position. It'd make this area positive, this area negative, and add it up. And that would be the change of position over the first 1.5. Plus, now we got to find the area from 1.5 to 4. So we'd have the integral from 1.5 to 4. And this line has a slope of 1, so it'd be t. And see, the y-intercept is going to be down here. It's going down to -2.5, -3, -3.5. So there would be the integral notation for the area of the total change in position. Use the provided graph to determine the value of the total change in position. Well, that would be, this would be plus area, this would be minus area, so those would cancel. And this would be plus, and this would be minus, those would cancel. So all I have to do is count the area of this. So that's 1, 2, 3, 4, 5, 6, 7.5, plus another half is 8, 9, and this would be a half, 9.5, plus a half is 10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's 10.5. So I got a 10.5 squares, and each square is how much? Let's see. That would be a half wide and a half tall, so each square is a quarter. So times 1/4, which would be, if I multiply by, make this 2/8, that would make it 21/8 is the total change in the position. Now it says write an expression finding the total distance. And when I was doing this class, I didn't notice it was distance instead of position. So now we just need the total area, not ignoring the negative. So we can put absolute values on the functions here, or we can write it in pieces. We'd have the integral from 0 to a half of the equation minus 2t plus 1 dt plus this area, which would be from 1/2 to 1.5, 0.5 to 1.5. Now we'd have to, this is going to come out negative, so we have to change it. So we're going to do the negative of that. and then the same equation, negative 2t plus 1. Or I could have put the negative on this and made it 2t minus 1 plus, then the area from here to here we have to change to positive. So that's from negative 1, from 1.5 to 3.5, and that's t minus 3.5 dt, but that would come out to be negative, so we have to change the sign so it's positive. So we're just adding the distance, plus that last little bit, which would be from 3.5 to 4 of t minus 3.5 dt. So there's the integral. We could have also just put absolute value on this part and absolute value on this part, and that would have been the same as doing this. Okay. What's the object's exact average velocity? Well, the total area, the total change in position we had here was 21/8. And if we flatten it out, there's more negative area than positive, so it should be down here someplace if we flattened all this. Subtract that from that, subtract that from that, and take this part and flatten it out. It'd be somewhere down here around negative a half. But we take the total area, all these areas, the total change in the position, and divide it by the width of the interval. Well, it goes from 0 to 4, so 4 minus 0 is 4. So we divide it by 4 or multiply by 1/4, and we get 21/32, which that's close to 2/3, which is right about there, which is about, makes sense. Then it says, write an algebraic formula for the object's position on the interval from 0 to 1.5. Well, that would be the antiderivative of this, which is, the antiderivative of negative 2t would be negative t squared. Antiderivative of 1 would be t, because the derivative of t would be 1. The derivative of negative 2t negative t squared would be negative 2t. And if we use that as s of t, would its position be 0 at 0? If I put in 0, 0 squared is 0 minus 1 is 0 plus 0. That satisfies that condition. So there's the position equation. Okay, that was 7. Now let's go to 8. Suppose the velocity of a moving object is given by t times t minus 1 times t minus 3, measured in feet per second, and it works from 0 to 4. Write an expression involving definite integrals whose value is the total change in position of the object. Well, that would be the integral from 0 to 4 of the velocity, which is t times t minus 1 times t minus 3 dt. Use appropriate technology, maybe that one in the book, to compute the Riemann sums on that position from 0 to 4. You work to ensure that your estimate is accurate to 2 decimal places, and explain how you know that to be the case. Well, I'm going to show you guys something on a calculator that we can do that with. It has the ability to do Riemann sums, to do these integrals. So turn it on, go to y equals, clear that, and put in this equation, except we use x, so x times x minus 1 times x minus 3. And let's just take a quick look at that. zoom 6. What did I type in wrong? Clear. Y equals, oh, I forgot a parenthesis right there. Second insert, a parenthesis. Now, zoom 6. That's what it looks like. Let's go zoom 4, get a little closer. All right, and we're supposed to find out on the interval from 0 to 4. So let's see if I can get that where it's not reflecting so much. So we want to know the area under from 0 to 4. So we have some positive area, a bunch of negative area, and then some positive area. And let's calculate the area from lower limit, 0, enter, upper limit, 4, enter, and it figured out that area to be 2 2/3. And I see that it's really close based on that decimal approximation on there. Okay, write an expression involving definite integrals whose value is the total distance traveled on the 0 to 4. Now we're doing total distance traveled. So from 0 to 1, we use what we have, and then from 1 to 3, we have to change the sign, and from 3 to 4, we use what we have. So we have the integral from 0 to 1 of v of t. I could write all that in there, but I just chose to write v of t. Minus, because we're going to have to do the negative of this part, from 1 to 3 of v of t dt, plus the integral from 3 to 4 of v of t dt, or we could have said the integral from 0 to 4 of the absolute value of v of t. Okay? Estimate the total distance on 0 to 4. All right. So now let's go back to here and change this equation to be the absolute value of this. So second insert, math, number, absolute value, and oops. All right. I'm going to put all that inside here. So x, parenthesis, x minus 1, close parenthesis, open parenthesis, x minus 3, close parenthesis. And there we have the absolute value of that. And now you'll see that that middle part is flipped up. So everything's flipped up. So this is still positive. This part that went down is now up, and this is up. So now we'll get the total distance, which, if we go second, calculate the area under the curve from 0, enter, 4, enter, and it gives us a total area of 8. Exactly. And what's the object's average velocity on 0 to 4 accurate to 2 decimals? So we just take the area under the curve divided by the width of it. And now we don't use, it's not the distance curve, it's the displacement curve. So we have 2 2/3, which is 6, 7, 8 thirds times 1/4, or 8 thirds divided by 4, which is 2 thirds. Now, if we were doing the distance, it would be 8 divided by 4, or 2, the average distance, but that doesn't make any sense. The average velocity is 2 thirds. In other words, if the object had gone at 2 thirds the whole time, 0 to 4, as opposed to going slow, fast, or whatever it does, you would have gotten to the same position. Okay. Number 9. Number 9, consider these two graphs of f and g provided. Each piece of f and g is either part of a straight line or part of a circle. So this is a circle, this is this part of a circle. These are all straight lines. Determine the exact value between 0 and 1 of f plus g. Well, f from 0 to 1 is, that's a height of 2, width of 1, triangle, so that's 1 from this part. And g, that is a quarter of a circle of radius 1. So the radius 1 circle has an area pi, so this is pi over 4. So 1 plus pi over 4. The exact value from 1 to 4 of 2 times f of x. So f of x from 1 to 4, this piece would cancel this piece, and so I'd have, this is 2 high, 1 wide, so this is 2, and this is half of that, which is 1, so that's 3, a negative 3 from 1 to 4. Negative 3 times 2 is negative 6. Now we got to do g of x from 1 to 4. So that's, this is going to be a little tricky here. This piece would cancel this piece. So we'd have to do this, which looks like it's about 2 squares, which is a half a unit. So 1/2, and this is a radius of 2, so that's 4 pi for a full circle. So this is pi, so 1/2 and pi times 3. So minus 3/2. Let's subtract 3, so minus 3 times that, this is positive, positive, minus 3/2, and minus pi, minus 3 pi. So minus, this equals negative 7 and 1/2 minus 3 pi. Okay? What's the average value of g minus f on 0 to 4? 0 to 4, f, g, we've got to find g first here, so this would be pi over 4 plus pi is 5 pi over 4 plus 1/2. No, let's see, take a pi over 4 away from pi. So 3/4 pi plus 1/2. 3/4 pi plus 1/2 minus f, and f was, let's see, this is 1/2, and this is cancels, and this was 1, 2, 3, 3.5. Oh, see, this is 1/2, that cancels this half, so we just get 1, 2. This canceled that, this canceled that, so we get 1, 2. 2. So f is 2, so we've got to take away 2, subtract 2. So we have 3/4 pi minus 1 3/4. That's the total area under g minus f, under h, and then we have to find the average value, so we have to divide it by the width of the interval, divided by 4. So it's 3/16 pi, and this is 4, 5, 6, 7/4, so it'd be minus 7/16 when we divide it by 4. There's the average value. Okay, so now it says from 0 to 4, add f and g. Well, this would be 2, negative 2. Oh, and we were supposed to subtract f, and f was negative, so that's plus. We have to add this. So this is 2 1/2. My mistake. 2 1/2. Add a half to 2, it's 2 1/2. And boy, I mean, several mistakes there. Okay, 2 1/2. Let's get that corrected. Plus 2 1/2, which is 5/2. And then we have to divide that all by the width of the interval 4. So that's negative 3/16 pi plus half, 2 1/2 of 5/2 divided by 4 is 5/8. Get that correct. All right, now f plus g. So this cancels that, that cancels that, so we get minus 2. And this was, I think we figured out to be 3/4 pi plus a half minus a fourth. This cancels that. So pi minus a quarter pi is 3/4 pi plus a half. So 3/4 pi plus a half plus f, which is minus 2, plus a half minus 2, which is 1 1/2, minus 1 1/2. So 3/4 pi minus 1 1/2. That's the area under here. So we want to do a curve that's a constant height that has that same area. Well, that would then have to be the average value. The average height of the curve is always the same. So it would be this divided by the width of the interval, 4, and that's the height that it would have to be. This has to be the average value if the area under the curve is equal to the total area. So that's the C is this, which is 3/16 pi minus, let's see, that's 3/2, 3/8 minus 3/8. 3/16 pi minus 3/8. And number 10. We have f is this and g is this. On the interval from -1 to 1, sketch and label the graph f and write a definite integral for the exact value bounded by that curve. Okay, so I'll go over here, and f would look like upside down parabola moved up 3. 1, 2, 3, and over 1, and over 2 would be 4. So we go to -1. 1, 2, -1. So from -1 to 1, that would be that area, the integral. So it'd be the integral of 3 minus x squared dx evaluated from -1 to 1. And it's a positive area. On the interval from -1 to 1, sketching this one, which was 2x squared. So here's g. X squared would be over 1 up 1, but times 2 would be up 2, and up 2, and it would look like that, from -1 to 1, and the height of 2. And so the area is this and that. And the integral would be from -1 to 1 of 2x squared dx. Write an expression involving differences of the definite integral so that the exact value, exact area that lies between y equals f of x and g of x on the interval. So if I put this one over on this graph, that would come down like this, and this area would be this area. So I did take the area between these two curves would be the area of this one minus the area of that one. So it would be just this minus that. Or if I wrote integral from -1 to 1 of 3 minus x squared minus 2x squared dx. That's for C. Explain why your expression in C has the same value as a single integral of that. Yeah, it would have been this minus this, which is the same as subtracting the two, the difference between these two. Okay, I explained that already. Explain why if P of x is greater than Q of x for all x on an interval, the exact area between them is those two heights subtracted. Yes, the area under P minus the area that's under Q, taken away from the area under P, take this away from this, you get the area between. That's what they wanted you to say.